Now let's nerd out with the normal curve, but using Python and working with it as a data scientist. So it was so painful to see you use that table, Carly. It was something I remember like seeing way back decades ago. And I think that there's a way better way we can do it as a data scientist.
Let's see.
So the way we actually generated the table was using Python. So to use the normal curve, we need to import a new library that we haven't used before.
Ooh, what's this one called?
This library comes from a whole collection of libraries called Scientific Python, or scipy. And inside scipy, there's a whole collection of tools. And we're going to just see a few of these tools. And you're going to see as a data scientist, scipy is going to be a common library you go to.
Okay.
So we're going to go from scipy.stats, which is scipy's stats models. And we're going to import norm. And this imports norm, which is the normal distribution, for use in our code. So this is no different than importing random or importing pandas as PD. We're importing norm here. We're just specifying it's from a certain library, but this is no different than everything else we're doing. So if we run this line of code, there should be no errors.
Oh, it says import invalid syntax. Import. I typed import. I need to type from scipy.
From scipy.stats.
Okay,
Yeah, this is a little confusing.
That was my bad. There we go.
Because normally we just say like import pandas, which means we're getting all of pandas. But scipy is huge, and we only want one part of scipy. Otherwise, we'd have to type scipy.stats.norm every time we run normal curve, and that's too much for me.
That is way too much.
So what we have is we have a few functions we're going to use from the normal distribution. So one problem that Carly loves to do is to find the area to the left of a z-score.
Percentile.
The percentile.
Yes.
And the percentile is also known as the cumulative distribution function, or the CDF. And the CDF says, how much area do we get if we accumulate all the area all the way to the left of some point? So to do that, the Python code is, for the normal distribution, we simply say norm.cdf. So we're asking for the normal distribution. What is the cumulative distribution function for the norm CDF of 1? So norm.cdf parenthesis 1 says for a z-score of 1, what's the area to the left of 1?
And it's actually the same thing as my incredibly cringe normal table, 0.8413.
8413. And you'll see in Python, you get 15 decimal points out. So it's incredibly precise. It's going to give you all of these decimal points to give you a lot of detail. So if you're adding, subtracting, or using really small numbers, you still keep that precision with Python.
Perfect.
So we can use, just like Carly said, that the normal curve is not just positive numbers, it's negative numbers as well. So I might want to know what's the area to the left of a z-score of negative 1.5. So it's the same syntax, norm.cdf of negative 1.5.
And this is really nice because the normal table actually didn't have negative numbers on it. So we had to do some calculations to kind of figure out what the area to the left of those negative numbers are. But Python allows us to just type in norm.cdf of negative 1.5, and I got 0.0668.
0.668. So 6.8% or 6.68% of the curve is colored in right here. So before we even type this code, so I'm going to say what's the normal, what's the area to the left of exactly 0. So I'm going to eventually type norm, or Carly's going to eventually type norm.cdf of 0. But what do we expect this result to be, Carly?
Oh, so this one, so 0 is right in the middle of the normal curve. And the normal curve is nice and symmetrical about 0. So that should just be half of the data, or 50%.
So the area to the left is expected to be 50. So I expect to see our result to be exactly 0.5.
Yeah, and the nice thing about z equals 0 is that's the average of the standard normal curve. It's also the median. And we know that the median is the 50th percentile, so it makes sense that there's 50% of the data to the left of 0.
So if we go ahead and do norm.cdf, what does Python give us?
0.5.
And 0.5 exactly. Awesome. One thing that's really useful to do, that you can do with the normal table, but I think it's incredibly hard because you have to search through the entire normal table for this. For questions that I want to know what z-score accounts for 10% of the data.
Ooh, yes.
So where is 10% of the curve shaded in, and I want to stop at exactly that point. How would you approach that?
So what I would do is, if I was using the normal table, I would basically find that percentage on the table and then look to the left and up at what z-score it matches with.
So you search the table.
Which is a little tedious, yeah.
So luckily, there's what's called the probability point function, and that's the exact point where the probability is that percentile.
Got it.
So this is abbreviated PPF. So we can do norm.ppf, and we want to specify, we want it to be at 10% or 0.1. So if I do norm.ppf, it's going to give me a z-score for what area of the table, or what area of the curve do I get to when I have exactly 10% shaded.
And it gives me negative 1.28.
Negative 1.28. So this is a z-score of negative 1.28, and everything to the left of negative 1.28 accounts for 10% of the area under the normal curve.
And that makes sense. If we put in any value into the norm.ppf that's less than 0.5, we should get a negative z-score.
And let's just make sure this works, because in theory, the norm.cdf now of our result of negative 1.28 should be very, very close to 10%.
0.100.
100. So we see that they're inversions of each other. So if you have a z-score and you need a percentile, norm.cdf. If you have a percentile and you need a z-score, norm.ppf. So let's look at this. What about the area to the left that's 99%? So if you are a 1%er, what z-score do you need to be a 1%er? So this will be norm.ppf. So what area to the left to get to 99% of the data shaded in? So to be a 1%er, I need a z-score of
2.33.
2.33. So we know that 99% of people, or 99% of data, when the data is normally distributed, is to the left of 2.33. So if you have a z-score of 3, you're in the top 1%.
Ooh, hopefully that's an income.
And now I'm actually wondering, one thing I love to do is I like to nerd out and think about what happens when you do extremes. So I don't want to just do basic values. I want to be like, I want to know where is 150% of the data to the left. So as a statistician, what's 150%?
Not a thing.
So let's see what a computer does when we ask norm.ppf of 1.5, which is 150%. And
Nan.
the result is nan. So nan is, why do we see the result? So nan stands for not a number. So not a number. And Carly, we receive a result because, like you said, 150% is an illegal percentile. There's not 150% of people.
Exactly. Percents are between 0 and 100.
So now we can do a couple final puzzles to really kind of think about some of the more challenging questions Carly had. So what percentile is shaded between z equals 1 and 2? So I'm going to follow Carly's model of actually drawing the picture out. So I'm going to draw a normal curve. I'm going to try again at drawing a normal curve.
They're hard to draw. It's taken me years to perfect it.
And I know that I want the area between z equals 1 and z equals 2. So I still need to use this idea of I'm going to subtract the area to the left of 2 from the area to the left of 1, and I'm going to subtract these areas out so that I can basically say I want to do norm.cdf, what percentile of the curve is to the left of 2 minus the area to the left of 1. So norm.cdf of 1. So this is going to tell me the total area just between 2 and 1 because I'm taking all the area left of 2 and subtracting what's left of 1, giving me just the area between 2 and 1.
And I got 0.1359.
1359. So I know about 13.59% of the data is between 1 and 2. And then likewise, what percentage of the area is to the right of z equals 0.107? So if I look at the normal curve, I have 0 right here, and 0.107 is just to the right of 0. And I wanted the area to the right of it. So I only have CDF, which gives me the area to the left, just like our table. So that's going to have to be 1 minus the area that's not shaded. So 1 minus norm.cdf of 0.107. And 1 minus the area to the left is going to be the area to the right.
And that gives me 0.457.
0.457, which makes sense because it's only slightly right to the middle.
Should be just less than 50.
Yes. So I find that this is a much more intuitive, kind of natural way to do it as a computer scientist. So I try and never use the table again. And I think that having Python gives you a lot more accuracy, and it makes it really quick to just answer questions about all sorts of random numbers, as well as do the inversion.
This is the amazing part of data science, that we can combine statistics and computer science to make our lives easier.
But if you didn't have the statistics, you wouldn't know how to get a z-score in the first place, because all Python knows is how to work with z-scores. So without knowing standard deviation means and how to do the conversion to z-scores, this is absolutely meaningless.
Exactly.
So keep nerding out with z-scores as we dive into more and more statistics and computer science to make you a great data scientist.